And chapter 5 is about Google Cloud. In this chapter, we will use Google Cloud Platform to develop serverless application and explore differences between Google as a cloud provider and Azure and Amazon as cloud providers. To create these applications, we will use cloud solutions, we will use cloud functions, HTTP request, Google Cloud Storage buckets, and cloud pub/sub topics. To create these applications in this chapter 5, we will use cloud functions, HTTP requests, cloud storage bucket, and cloud pub/sub topics. Four different topics. We will also explore different use cases for HTTP and storage triggered functions, so we get a better understanding of the breadth and depth of serverless applications. By the end of this chapter, we will have 3 serverless applications and experience with several Google Cloud services. So this chapter is about Google Cloud, and we'll be doing examples. What we've done in the previous 2 chapters, we studied AWS from Amazon, and we studied Azure from Microsoft. Now it's time to study Google's product, cloud solution. At this book's publication, Google Cloud is currently in a beta release of Cloud Function. This is printed in 2018. By the time of reading this book in 2022, like this year, 2022, 4 years later than writing this book, things changed a lot, and many more services are added to the cloud of Google. The APIs might be changed in backward and compatible ways and are not subject to any SLA or deprecation policies. Keep this in mind while we go through these exercises. Just keep this in mind that things are changing. If you want to see the current Google Cloud, go to the cloud.google.com, right? Or search it. Just search in the Google, just type Google Cloud Solution, and things will show up. All right, exploring the user interface, we are going to start investigating the Google Cloud user interface before developing our functions. I would recommend some self-exploration beyond this section. Keep attention to this word: self-exploration, self-learning, self-teaching. So developing programming is all about self-doing things. You do it by yourself, right? Why? Because things changes. The user interface can change, things can change. So, and the online articles from Google itself, it might change, right? So just keep that in mind. Azure and AWS have many differences, but to me, Azure and AWS have many differences, but to me, there was definitely more of a learning curve with Google. I think a lot of this had to do with my comfort with AWS and the new concept introduced in Google Cloud. So Google introduced new concepts, and the author is familiar more with the first thing she learned, which was the AWS from Amazon, right? To get started, we will need a Google account access to the cloud user interface after signing into the console, which is https://console.cloud.google.com. After, you need to create an account first, and your dashboard will display a list of Google services separated by functionality, very similar to AWS and Azure. Figure 5.1 gives an idea about the Google stuff. So here we have the Google Cloud Platform, and we have the dashboard, and we have project info, resources, compute engine, Google Cloud Platform, billing, error reporting, news, APIs, trace, and here we have the Cloud Launcher, billing, API support, IAM and admin, VPC network services, VPN, app engine, compute engine, container engine, cloud functions. And this figure 5.1, Google Cloud Platforms offers many services ranging from compute services to networking services to storage. We will be exploring these. We will be exploring functions, API manager, storage, and AIM. So the functions will be stored, API manager, storage, and IAM. This is the storage, right? So not everything will be stored, will be explored in this chapter. It's just as getting familiar, just as start off, just to get started. At this point, you have learned a lot of different terms for the same concept in Amazon and Azure. Table 1.5 provides a concept map for the three platforms to keep the terminology straight throughout this chapter. See the concept, the AWS term for it, the Azure term for it, and the Google term for it. When they say data center, in AWS they say region, in Azure they say region, in Google term they say region. When they abstracted data center, in AWS they say availability zone or zone. In Azure they say availability zones with S, and in Google term is just zone, right? Age caching. AWS calls it cloud front for age caching. Azure, they don't have age caching. Google, they have POP, multiple services, POP. The concept is compute IaaS, AAS, which is infrastructure as a service. In AWS, they call it EC2, infrastructure as a service, like the infrastructure. In Amazon, they call it EC2. The infrastructure as a service in Azure, they call it virtual machines. Virtual machines. In Google, they call it Google Compute Engine. Compute Engine, right? The compute PaaS, which is programming as a service. And in AWS, they call it Elastic Beanstalk. Elastic Beanstalk. In Microsoft Azure, they call it App Service, Cloud Services. In Google, they call it Google App Engine. App Engine. Compute containers, in the containers, in Amazon, they call it EC2 Container Service. In Microsoft, they call it Azure Container Service, and they call it Service Fabric. In Google, they call it Google Container Engine. So containers is always the word container is there. This is the like something that they all agree on. All right. The same with load balancing. Network load balancing. In Amazon, they call it Elastic Load Balancer. In Microsoft Azure, they call it Load Balancer. In Google, they call it Load Balancing. Balancing, almost the same. So load balancing is also the same. Network peering. The peering in the AWS and the Amazon, they call it direct connect. Direct connect, or sometimes they call it direct connect, all right? And in Microsoft Azure, they call it express route. The peering, they call it express route, the peering concept. And the peering concept is called in the Google, they call it cloud interconnect. Cloud interconnect. Cloud interconnect. The network DNS, domain name service, In AWS, Amazon, they call it Route 53. In Microsoft, they also call it DNS. And Google, they call it Cloud DNS because it's a Cloud DNS. Right? So this is smart, really, and the Google one is more logical. Anyhow, away from my opinion, the storage object storage in the Amazon they call it S3. In Microsoft Azure they call it Blob. In the Google they call it Cloud Storage. And storage, file storage, the concept is file storage, not object, file. In AWS they call it Elastic File System. In the Microsoft Azure they call it file storage. In Google they call it Aver or Avere, I'm not sure. And we have the database RDBMS. In AWS they call it RDS. In Azure they call it SQL database. And Google they call it Cloud SQL. And the database NoSQL in AWS they call it DynamoDB. We explored that when we studied the AWS DynamoDB example. And in the Microsoft Azure they call it table storage. NoSQL they call it table storage. And for Google term they call the NoSQL they call it Cloud Data Store or Big Table or Cloud Data Store. That was the NoSQL concept. And finally, for the messaging, for the AWS, it's SNS. For the Microsoft, it's called Service Bus for the messaging. Here it's called SNS, and here it's called Service Bus. And in the Google term, it's Cloud PubSub. And we went through a third-party example that called Twilio, right, in a previous chapter, to send text message to mobile phones, right? And it was a global service. So for messaging concept, the Amazon, it's called SNS. For Microsoft Azure, it's called Service Bus. And for the cloud, it's called Cloud PubSub. Cloud PubSub, all right? This chapter is about Google Cloud, so let's proceed. That table is about the terms or concepts. This is a good reference to keep because, as you can see, the different naming between different service providers, right? Let's proceed. Navigation. The dashboard of Google Cloud is pretty straightforward and very accessible. As in Azure, you are able to configure and customize the layout of your dashboard to what works for you. Also, similarly to Azure, Google Cloud provides user with a Google Cloud Shell. Google Cloud Shell. This is found in the top right of the blue bar across your dashboard. Google Cloud Shell is an environment for managing resources hosted on Google Cloud Platform. What is the Google Cloud Shell? It is an environment for managing resources hosted on Google Cloud Platform. Again, what is the Google Cloud Shell? The answer is it is an environment for managing resources hosted on Google Cloud Platform. The shell already has the Cloud SDK up and ready to go. I like this because it's less setup on your local machine and makes it all very accessible through the portal. To test this out, you can open Cloud Shell and type in Google G Cloud space-version. This will give you a list of installed Cloud SDK components and their versions. Just like that. Cloud Shell comes with the Cloud SDK up and running along with several components. All right. In the dashboard, we have access to our project info, resources used, billing, and other reporting. The specific project you are in is displayed on the top left of the blue bar. Right now, I'm on the Hello World project I created for this tutorial. Hello World. Figure 5.2, right? To create a new project, you can click the drop-down arrow on the blue bar, and project model will pop up. If you click the plus sign, you can create a new project and add it to your dashboard. Feel free to do this for the Hello World function now. Any cloud platform resources that will allocate and use must belong to a project. I like to think of projects as the organizing entity for what I'm building. A project is made up of settings, permissions, and other metadata that describe your application. A project is made up of settings, permissions, and other metadata that describe your application. All right, resources within a single project can work together easily. And here's an example. For example, by communicating through an internal network subject to the region and zone rule. The resources that each project contains remain separate across project boundaries. You can only interconnect them through an external network connection, right? And let's read this. By clicking the set of dots next to your profile picture. So if you go to the next to your profile picture and click these dots here on the top right. By clicking the set of dots next to your profile picture, you have access to a list of other options, including project settings for the given project. When you click this, you see a project ID and project number. These are two ways to identify your project. So what identifies your project? The answer is the project ID and the project number. As you work with cloud platforms, you will use these identifiers in certain command lines and API calls. Project number is automatically assigned when you create a project. Project ID is a unique identifier for a project. When you first create a project, you can accept the default generated project ID or create your own. A project ID cannot be changed after the project is created. So if you are creating a new project, be sure to choose an ID that will work for the lifetime of the project. In the same panel, you are able to access IAM permissions and roles for the project. This is a feature that Azure and Google share that AWS doesn't, definitely. And both Azure and Google services, the resources are split by project from the console down. In AWS, you can do this, but it is not something that is provided out of the box. This means that while navigating through AWS, you would see resources for different projects in the same space and would have to specify IAM policies for specific projects. Google and Azure enforce this separation of projects. Any change you make to Google or Azure policies for a project applies to the entire project. And the pricing for Google can be seen in figure 3.5. And here's an overview. You can create budget attached to specific projects with a specific amount of various alerts. These alerts will email you when the minimum value submitted has been reached. Google also provides a pricing calculator that is intuitive and easy to use. The other providers we have covered provide this as well. If you are just working on independent projects, the cost calculator probably matter less to you. But if you are ever doing any cloud architecture and development for someone else, the cost calculator becomes pretty important. Google's cloud calculator lets you pick the services you think you'll be using and define all of the specifications for each of them, so you will get a more accurate price calculation back. Figure 5.4 shows an estimate for the Hello World cloud function we'll be creating together. All right. The cost calculator lets you select the service information and add your current estimate for the amount of money per month. Total estimation cost is 0 per month. All right. Cloud functions. Cloud function can be accessed in the left panel under the compute and functions. Google also gives you a pinning option so you can keep your access to functions at the top of your screen no matter where you are in the console. I do this for easy access. The Cloud Function Dashboard lets you view your current active functions, region, trigger, memory allocation per function, and the last deployment. This is also where you would go to create or delete a function. Figure 5.5 gives you an overview of the Google Cloud Dashboard. So here's the Google Cloud Platform and Cloud Functions and create function and refresh and all that stuff. The Cloud Functions dashboard shows you active functions and their metrics. We will walk through creating a function when we begin our Hello World application. But for now, I'm going to give you a quick background on more specific differences in Google Cloud functions that Google Cloud specifies in their documentations. Security, IAM. Security, IAM. Google Cloud Identity and Access Management, IAM. Identity and Access Management. It enables you to create and manage permissions for Google Cloud Platform resources. So create and manage permissions through the Identity and Access Management. Cloud Identity and Access Management unifies access control for cloud platform services into a single system and presents a consistent set of operations. You can set access control using roles at the project level. Assign role to a project member or service count to determine the level of access to your Google Cloud Platform project and its resources. By default, all Google Cloud Platform projects come with a single user, just one user, the original project creator. No other users have access to the project and or its functions until a user is added as a project team member. Figure 5.6 demonstrates the IAM flow associated with Google Cloud. IAM and a policy, roles and identities. The roles, for example, compute.instanceAdmin, storage.objectAdmin, open join.appAdmin, logging, I think this is opening, I'm not sure, logging.viewer, pubsub.publisher, etc. Identities, Google account, test@gmail.com, service account, test@project.id.iam.gserviceaccount.com, Google group, test@googlegroup.com, and Google app domain, test@example.com. The IAM service attaches a policy to roles and identities to provide secure access. So they attach policy to roles and identities. Iam Console, figure 5.7, which is down here. This is the Iam Console. It demonstrates an overview of all your IAM resources along with 5 security steps you are recommended to complete, right? The IAM console found under the list of products and services on the left dashboard blade. The console gives you the dashboard with the current IAM permissions for your project identity, quotas, service accounts, labels, GCP, privacy settings, encryption keys, proxies, and roles. The dashboard lists the permissions for a particular project you are in at the moment. These permissions affect the entire Hello World project and all of its resources. To grant permission, add a member and then select a role for them. So, to grant permissions, add a member and select a role for them. Again, to grant permissions in the IAM dashboard in Google Cloud. To grant permissions, add a member, then select a role for them. Members can be people, domains, groups, or service accounts. Members can be people, domains, groups, or service accounts. 4 things. Note, at this book's publication, some rules are in beta development and might be changed or deprecated in the future. Again, the same note that was mentioned at the beginning of this chapter, it's repeated here. And like all what we are talking about can change because it's under development, right? Roles. With the Cloud IAM, Cloud API method requires the identity making. The API request has the appropriate permissions to use the resource. You can grant permissions by granting roles to users, group, or service accounts. There are 3 types of roles that we will look at: primitive, predefined, and custom roles. So we have 3 types of roles: primitive, predefined, and custom. And each one is mentioned here. Primitive roles are roles that existed prior to Cloud IAM. Owner, editor, and viewer will continue to work as they did before. Again, what are the primitive, the basic ones? Owner, editor, and viewer. These roles are concentric. That is the owner role includes permission. It's self-explanatory. So the first one is primitive roles and owner, editor, and viewer. Cloud IAM provides additional predefined roles. So the second one is the predefined roles that gives granular access to specific cloud platform resources and prevent unwanted access to other resources. You can grant multiple roles to the same user. For example, the same user can have network admin and log viewer roles on a project and also have publisher role for pub subtopic within that project. In addition to predefined roles, Cloud IAM also provide the ability to create customized roles. So we have the primitive author, editor, and viewer. We have the predefined that you can predefine whatever you need. And we have the customized, the third type, and you can create a custom IAM role with 1 or more permissions, then grant that custom role to users who are part of your organization. So it's basically something kind of obvious if you are computer literate, right? Policies, you can grant roles to users by creating Cloud IAM policy, which is a collection of statements that defines who has what type of access. So what is the policy? It's a collection of statements that define who has what type of access. Who has what type of access? A policy is attached to a resource and is used to enforce access control whenever that resource is accessed. A cloud IAM policy is represented by the policy object. A policy consists of list of bindings. A binding binds a list of members to a role. The following code snippet shows the structure of a cloud IAM policy. The last thing to understand about policies is that Google Cloud organizes them hierarchically. This hierarchy is defined by organizations, projects, resources. Figure 5.9 shows an example of cloud platform resource hierarchy. The organization node is the root node in the hierarchy, which is on the top, the organization. The projects are the children of the organization, children of projects. And the other resources are children of projects. Each resource has exactly one parent, right? Just like that. The list of roles available through Google Cloud, you can also create a role. And in the next video, we will start our first Google Cloud code. See you later.